So hello everyone. Today we are going to solve one of the contests. So some of you have commented that you want some solution for some contest. So let's see the question of the recent bi-weekly contest 180. So let's read the first question. What it says: traffic signal color. So it's a easy problem. Basically, what is the point distribution? 3, 4, 4, 6. Okay. So the traffic signal color. Let's read the problem. You are given an integer timer representing the remaining timer on a traffic signal. The signal follows these rules. If timer is 0, the signal is green. If it is 30, the signal is orange. And it is between 30 to 90, the signal is red. Return the current state of the signal. If none of the above condition are met, return invalid. Okay, so basically for basic, simple basic if else question, like I hope everyone has solved it. So we will just check the statement. If time equal to 0, like timer, and else if timer equal to 30, else if like 30 less than timer, and then timer less equal to 90, and else. Okay, so for this we will return green. Green. Okay, for similar we will return orange for 30. Orange, and for this we will return red, and lastly we will return invalid. Think that's good. Let's run this and submit it. So it should work. Yeah, it got AC. So it basically was a very simple if else question. So let's move on the another question. So count digit appearance. So what it says, you are given an integer array nums and an integer digit. Return the total number of times digit appear in the decimal representation of all element in nums. Okay. So basically here like the number are 12, 54, 32, 22 and digit is 2. So we have to count like in this total array how many times 2 appears. Like in 12 2 appears 1, 54 none, 32 2 appears 1 and in 22 2 appears twice. So total 4 times. So what we can do, we can simply iterate over each element and we can count that how many digit 2 are there. So for that we will just store answer, and for we will iterate over every element x, and now we will just count how many digit this digit are there in the x. So we know how to extract digit, like uh, while x is greater than 0, what we will do, we will just increase the answer plus equal to 1 if x mod 10 equal to digit. Okay, and then x by equal to 10, and lastly we will return answer. So what we have done here, we basically know how to extract the digit, and then we will mod this with 10 to find the digit, and if this is equal to digit we will increase the by answer. Basically this is simply equal to if x mod 10 equal to digit, then answer plus plus. And we can also write this like this: if it is true we will increase the answer by 1. Okay, let's run this. It should work. Yeah, now submit this. So first two question were very basically simple and straightforward, nothing to we have to think about it. We can also count this in a string manner, like we can convert this number into string and then we can use the library function count. So to convert these to string, we will use toString function. To string x will convert this into string, and we will use like library function count to string comma the character, that is digit plus 0. Mm, answer plus 12. So this should also work. So what we have used? We have used ranges count basically. Ranges is a sub namespace like where we use all the range based container and algorithm where we have to pass the container, not the like the start and the end iterator, and it will work. So if we submit this, it will also work. Yeah. So let's move on to the next question. So first two, three and four pointer were very easy and straightforward. Nothing we have to think about this. Now here minimum operation to transform array into alternating prime. Okay. You are given an integer array nums. In array is considered alternating prime if elements at even indices are prime and odd indices are non-prime. Okay. So what is the operation here? In one operation you may increment any element by one. Okay. Return the minimum number of operation required to transform nums into alternating prime. Okay. Okay. So here we can only increment this by one. So what we can do, we can basically find for a prime number, like in the even indices we are expecting prime number. So if there is no prime number, like there is not currently not prime number is there, so we will increment it until we find next prime, or we can use binary search to find the closest prime next to it. We can do any of the approach. So for that, what we can do, we will just iterate over the element in nums. Now we have to get the size, then answer also initialize with 0. Now we have to iterate it in great ways to find that index is even or odd. So if I and 1 else. So I and 1 mean odd index. So in the odd index we are expecting non-prime. So what we can do? We will do while, so the current number is nums of I, right? So while this number is basically we are expecting non-prime here. So while it is prime, we will just increment it value num plus plus and also increase answer plus plus. And similarly in this case, in the other case, if the number is not prime, until it is like while it is not prime, we will increase it uh, like when we find our first prime. Also we can use binary search, like we can find all the primes, and for this we will find in binary search way like what is the next prime of the number, and here also we have to store all the non-prime number, and then we have to binary search that what is the next non-prime number. So and last we will return the answer. Now we have to create this prime array. So what is the range of the number here? Number is up to 10 to the power 5. So we know that the prime gap is very less, like the maximum gap from one prime to another prime up to 10 to the power 5 is very less, like maybe 100 or 120 something order. I have not like remembered it exactly, but it is nearly about 100 or 120 something, the maximum gap. So it won't create any issue. So now we are going to create this prime array. So for that, up to 10 to the power 5, so we can take this maximum to 2e5 also, like it is 10 to the power 5, so 2 into 10 to the power 5 is good. Now we will take a Boolean vector prime, Boolean array basically, and we will also sieve operator finish, so to create this. So we are using sieve here. So in the sieve, first of all, we will basically fill. We can use memset or we can also use fill prime plus n comma true. We will fill all of the vector with true. Let's first assume that all of them are prime. Now what we will do, we know that basically prime of 0 and like prime of 1 are false, means 1 and 0 are not prime. Now we will just go, sorry, from 2. mm, Here I am writing the basic C operator things code. So here now for uh, so from 2, what we are going to do, uh, and I into I less than n, from j equal to I into I, j less than n, j plus equal to I, we will simply do prime of j equal to false. So what we have done basically, we have traversing over all the prime number and then marking their multiples to false. Basically, if a number is a multiple of a prime number, then it is not a prime. Uh, so I think that's good. Now call it from here. Save. Now let's run this. It should work. Yeah. Let's submit this. It should pass. So it got accepted. So here another thing, like whenever we are like calling this function, it is calling sieve. So sieve is doing so much pre-computation here, like up to 10 to the power 6 order. So we can reduce it, like reduce it in the sense, if from a same main function we are calling it multiple time, so we don't need to pre-compute this every time. So what we can do, we can use a boolean flag in it. So basically initialize it with false. So it will signify like have we already initialized the prime array or not. So here, if it is already initialized, if init is true, then we will simply return. We are not going to recalculate this, and otherwise we are just do init true. After doing all the calculation, we are setting it true. So if this function is going to call from the main function multiple time, it won't like compute this whole thing multiple time because we are checking this. If it is already initialized, we are not going to recalculate it, and after calculate it for the first time, we are setting it true. So let's submit it again. Like nothing will change, just we are not going to do this time so much of recalculation. Yeah. Now let's check for the last. So maximum value of concatenated binary segment. You are given two integer array nums1 and nums0, each of size n. Nums1 of I represent the number of ones in the ith segment, and nums0 of I represent the number of zeros in the ith segment. So for each index I, construct a binary segment consisting of nums1 of I concurrence of 1 followed by this. You may rearrange the order of this segment in any way. After rearranging, concatenate all segments to form a single binary string. Return the maximum possible integer value of the concatenated binary string. Since the result can be very large, return it modulo 10 to the power 9 plus 7. Okay. Sorry. So what the question said, like we are given in segments and we know every segment has some 1 followed by some 0, and we know the number of 1 and zeros for each segment. Now we are going to like create the segment, and we can rearrange the segment to make a large concatenated binary string, and we have to maximize it. So basically here, like nums of 1 is 1 and nums of 0 is 1, means one segment will be 1 0 and another will be 2. Like in another segment, number of 1 is 2 and number of 0 is 1. So these are the two segments. Now we have only two choice. Like either we can keep in same order. Also we can do like first 1 1 0 then 1 0. So which is the maximum? Like here this is the maximum. What is the value of this? This is 14. So that's thing I think. Oh sorry, here it is 0. So this will be 0. So now there will be two choice, either this or this. So obviously this is greater. So here you can see one segment is 1 0 and another is 1 1. So there can be two possibilities like 1 0 1 1 or 1 1 1 0. So for like multiple segment, we have to rearrange this in such a way that after concatenation the binary string produce the maximum value. So in the second case also we have two segments. First one is consist of 3 1 and 0 0. So basically 1 1 1, and another segment is 1 1 and 3 0. So 1 2 3. So these are two segments. So here also we have two choice like this or three zeros and 1 1 1. We know this is the better, like the maximum value producing. So we can do this. So what we can do? So first of all, we can create these segments. Like we will generate this segment, that is very easy. Like the number of ones are also given and the number of zeros are also given, so we can easily create them. Now the tricky part is like how we will rearrange, or like how we can find the optimal rearrangement so that this produce maximum. So it's basically a standard problem. Like there is a problem where similar kind of problem, like we are given some segment of string and we have to, after some rearrangement, we have to find the lexicographically largest string or lexicographically smallest string, like the same problem. So here also same problem, like we have to find here the lexicographically largest string. So we know the lexicographically largest binary number will produce the maximum value for sure, because like there are suppose two number, uh, some one, and this has like 0 here and this is 1 here. So this is lexically bigger, the second one. Like this is the first one and this is the second one. So now it doesn't matter that what value are there. Basically, if it is all uh, the position are 1 and this is by 0, still this number 2 will be maximum because the MSB here is different. So we have to just find the lexicographically largest string after a rearrangement of all the segments. So for that, we're just, what we will do, we will just find first the size of the array, nums1 dot size. Now we will create a segment of string size n, and we will create all the segments. So we will traverse, and we know the number of 1 are nums of 1 of I, and number of 0 in there is nums of 0 of I. So what we will do? We will do segment of I equal to, either we can create the string manually, or we can use the constructor function of the string, that is string this comma the character we need, the number and the character. We will concatenate this with string this comma 0. So I think this will create our string, the number of character we needed and the character. So we have created the segment. Now we will rearrange in a optimal way. So let's for now let's consider that in somehow we have rearranged it in optimal way. So it become like so will largest. So next compute the value. So how to compute the value? We will just create a string binary, and what we'll do, we will just in the segment we will just concat all the thing. So we are creating the large binary number actually. Like we have not wrote down anything here. We will do that later. So let's for now consider that we have rearranged it in some optimal way. Now we are calculating the answer. For that we will traverse over the segment and we will just add this in the binary. So our binary string is ready. So now let's name this as prepare the binary string, right? Now here we have to compute the value. So how we are computing binary value to the decimal? We know if some number is 10110. So the power of two are here like 0, 1, 2, 4, 8, 16. So let's reduce this one place. So this will be 8, then 4, then 2, then 1. So for this one, the value of like the power of 2 here is 1. Now here the power of 2 is 2. This is 4 and for this is 8. So we will write this as like 1 into 8 plus 0 into 4 plus 1 into 2 plus 1 into 1, which will be equal to like 11. So what we will do, if we have some binary string, we will just track the power of 2 for this current position, and if the current position is 1, we will just add that value to the answer. So the answer will be for like here in the first position. When we are in the first position, the power is 2. So we'll add the answer to 1. Then here the power is 2. So we will add the value 2 to the answer. Here the power is 4, but the character is 0, so it won't contribute anything. Now here the power is 8, so it will contribute to the answer. So what we will do, answer, and also we will take power which is initially 1. Now we will go in the binary string from the reverse manner, like from last to first. So for that, the normal like you can either reverse the binary string or you can traverse it in the opposite direction. So either of them work. So in binary, so I'm using some library here, like reverse library, which will like traverse it reversely. You can simply like reverse the binary array and then traverse it, or you can do just like this. Uh, what it do, it basically pipe this with this ranges reverse function, which will like iterate this binary string reversely. So now, if the current character is 1, then we will add the answer, add the power to the answer. And in every iteration, we will increase the power by 2. And lastly, we will return answer. So this is the simple like code to compute the value. So now here we have to do some modular arithmetic because the answer can be very large. For that, we will use mod here. 1e9 plus 7. So this is our mod. So here answer plus pow, instead of this we will do answer equal to answer plus pow mod m, and here also we will do 2 into power mod m. So it looks good. Now we have to find like how we can rearrange so that it become lexicographically largest. So for that, what we will do? We will do some sorting. In the sorting, like what will be, we have to write the custom comparator here. So I'm write the sorting here. Sort, we will sort the segment, and we will write the custom comparator here, which will take two string. Now we have two string s1 and s2. We have to determine that which will go first. So if you don't know how to write custom comparator in sort function, first learn that. Then this is very standard, like to find lexicographical largest string. We just check that s1 plus s2 should be greater than s2 plus s1. This is the condition here. So basically S1 will stay before S2 if after concatenating them it become larger than the concatenating them in the reverse way. Like if we concatenate S1 and S2, it should be larger than S2 plus S1. Then only the S1 will stay before S2. So that is the thing. So I think that's it. Let's run in on the samples. It should work. So what we have make mistake here, like invalid operands to binary expression string. Okay, binary ranges reverse. Let's check this if I have written something wrong in the syntax or something. Mhm. Okay, we have to use the views library here, not the ranges. So basically it will create a view of this string. Or you can simply use reverse this binary and simply iterate it. That will also work. So why we are using this instead of the, like this is the sub namespace ranges where we handle the range based container and the algorithm. Like if you use use the old function, it ranges namespace came after C++ 20. So if you use old one, it will be like reverse binary dot begin comma binary dot end. So in the old HTML functions, we have to pass to iterator first and last to know the function that where it have to be applied. But in the range base, like in the ranges namespace, we don't have to. If we are operating like using the whole container there, then we can pass only by name in the ranges library. So you can do this, or you can do whatever I have done. Like here, without reversing it, you can just create a view of this and traverse it in the reverse way. It won't change the binary. The binary string will stay like the before, but it will just create a reverse view and it iterate over that. So it is not necessary. Like don't much focus into it. Let's submit this to check it is correct or not. So we got time limit exceeded here in the last test case. So why we are getting time limit exceeded? We are basically building all the segments as a string. Then we are sorting here. And if you look at this input very carefully, like Here all the segments are containing only one and no zero. So here while checking we are repeatedly concatenating them and checking them. So that's why it is creating the time limit exceeded. So what we can do, we can do the same thing without creating the string, only the count of 1 and 0. So we know that if a number has more 1, then it should come first than number which has less 1, because it will contain like, see the what we are going to do, we are doing the same thing. We have to just, we have like two segment, we have to choose like the order of them, which one will come before which. Like if a segment is 110 and another segment is like 101, then obviously like this segment should come first, because if this segment come first, this like here the 0 is here and here it is 1. So how we are going to like tell that which one should come first? Like, no, this is not a valid sequence basically. Now here, in this case, as this contain much more like more number of one, so the most significant bit like which contain one will be less. So what will be our idea? Our idea in this sorting will be like the segment with containing only ones will be the higher priority. So let's assign them as like priority 3, and there will be some segment with some 1 and some zeros. So let's assign them priority 2, and there will be some number with containing only 0. So they will be the least priority. So first we will assign them the priority. The segment containing only one will be the higher priority. The segment with both 1 and 0 will be uh, less priority than this, and the segment with only 0 uh, should be least priority. And after this we have to consider like uh, in this thing, like if the segment has all both 1 and 0, we have to check like which one will come first, which have more number of 1, that should come first. And if both the segment has the same number of 1, then the segment which has least number of 0, that will come first. So for that we will just create a vector of order to find the order of the segments, and we will fill this with like what iota function do. Iota basically fill this 0 with 0, basically create a vector with value 0, 1, 2, 3 in the incremental range. So initialize 0, it will basically create a array 0 comma 1 comma 2 comma 3 comma dot comma n minus 1. So it fill the order in this way. Now we will also create a vector of priority. Priority, let's initialize all the priority with 2, and if the segment has only 1, that means the number of 0 in this segment is 0. If this happens, that then the priority of I will be the maximum. And similarly, if it containing only 1, sorry, only 0 means this, then it priority will be minimized. Now in this sorting function, we will get, instead of string, we will get just two indices here. Now if the priority of I and j are different, priority of j, we are expecting that priority of I should be higher than priority of j. Okay, now here in this case, both the priority are same. So in that case, if it is, if the priority is not 2, priority of I Not equal to 2 means both of the segment has the same priority and that is not 2. So we will simply return false. Why? Because uh, only in the case of priority 2 where both 1 and 0 occurs, we have to check like which one will come first. Otherwise it doesn't matter, like if it is containing only 1, then it doesn't matter like which segment should come first. So we will return simply false. We won't check anything. And here what we will do now, uh, we are expecting that we will just return that number of ones in I should be greater than number of one in J. But what if they have both same number of one? If this equals number of one in J, then we will just return. We are expecting that number of 0 in I is less than number of 0 in J. So see the custom sort here. Now here uh, we can we can do this computation without creating the string also with the help of the map. But for the convenience, like for compute it simply, I'm just creating the string. So I have sorted the order in optimal way. Now we will go in order and then in the binary we will add the string of nums of 1 of I comma 1 plus string of nums of 0 comma I comma 0. Let's run this. This should work. So what does it say? Priority. I think I made some spelling mistake. Priority. Yeah, let's run this. Mm, Makes lots of typo. What? Okay, so it doesn't getting any priority because we have not captured in the address. Like we are not capturing the all the things from this code. Now what is the problem here? We're not sorting segment, we are sorting the order. This should work. Yeah, it got AC, so let's submit this to check what is going on. And it got AC. So basically our idea was right. We have to do the same way, but we were doing that in brute force way. We were creating segment of string and then we are sorting them. So that got us really in the last test case. But here we have not created the string and sort them. We just sort them basis on the count and then we create the string. Also, you can avoid this part. Like you can also compute the answer without creating the string also. Just use some power and math like the binomial function or math and modulus arithmetic to calculate this. For I am just creating the string here for easy computation. So that's all for today. Thank you.